Today we're going to be talking about exponent laws. So first, looking at what an exponent is, just a reminder, the exponent is the little number that is up top. The big number on the bottom is called the base, and the whole thing, putting the base and the exponent together, is called a power. So the multiplication law of exponents, we have the bases that are the same, and when the bases are the same, you can add the exponents. So looking at the first example here, we have 6 to the exponent 2 and 6 to the exponent 3. So that means 6 times 6 times 6 times 6 times 6. And when we put those all together, there's 1, 2, 3, 4, 5 6's. So 6 to the exponent 5 is what we get. The other way we do that, since they have the same base, they both have a base of 6, and there's multiplying in between, we add the exponents. 2 plus 3 gives us the exponent 5. Okay, so the next example is negative 5 to the exponent 3 times negative 5 to the exponent 4. So that is negative 5 times negative 5 times negative 5. And then we have times negative 5 times negative 5 times negative 5 times negative 5. So here we have 1, 2, 3, 4, 5, 6, 7 negative 5's. So negative 5 to the exponent 7. Okay, same bases, multiplication in between, adding the exponents, 3 plus 4. Okay, the last one we have a times a to the exponent 3. When we have a, there it doesn't show an exponent. When it doesn't show an exponent, that is 1. So that's a times a times a times a. And there's 1, 2, 3, 4 a's. So a to the exponent 4. Again, the bases are the same. You add the exponents. So 1 plus 3. Okay, so when you're doing this, it's not necessary to show all the work here. We just notice that they have the same base. You add the exponents. Okay, so looking here, we have x to the exponent 4 times x to the exponent 5. The bases are the same. They both are x. There's no operation in between, but that means multiply. So when we're multiplying same bases, then we get x and add the exponents, 4 plus 5. We get x to the exponent 9. Okay, so next one, we have 2y to the exponent 7 and 6y to the exponent negative 10. Again, there's multiplying in between here. The extra step that we have is that we have the numbers out front. We're going to multiply the coefficients that are out front. We have the same bases, so keep the base the same and add the exponents. So 2 times 6 gives us 12, and then we have y, and add the exponents, 7 plus negative 10. 7 plus negative 10 gives us a negative 3. So we get 12y to the negative 3. The last one here, we have 1/2 squared times 1/2 cubed. Our base is the same. They are both 1/2. Multiplying in between, so we can add our exponents. So that's 1/2, and adding the exponents, 2 plus 3. So we get 1/2 to the exponent 5. Okay. If we wanted to simplify this, the exponent 5 would go to both pieces inside. So it would be 1 to the exponent 5 and 2 to the exponent 5. So 1 to the exponent 5 gives us 1. 2 to the exponent 5 gives us 32. So our final answer here is 1/32. Okay. Next, looking at our division law. Here, the bases are the same. When we divide, we subtract the exponents here. So looking at the first example, we have 3 to the exponent 7 divided by 3 to the exponent 4. So we have 7 3's up top and 4 on the bottom. What we can do here is cancel some of our 3's. So cancel a 3, cancel another 3, another, and another. So what we're left with is 3 times 3 times 3, which gives us 3 to the exponent 3. The other way of looking at that, we have the same bases, dividing. 7 minus 4 gives us that exponent of 3. The next question is -4 cubed divided by -4 squared. So that's -4 times -4 times -4 over -4 times -4. Okay, we can cancel, and we're left with just one -4. So -4 to the exponent 1, or just -4 is our answer. Looking, same bases, dividing, so we're subtracting the exponents, and that's 3 minus 2, which gives us the same answer of 1. The last one here, b to the exponent 5 divided by b to the exponent 3. So here we have b times b times b times b times b over b times b times b. We'll cancel some out. And we are left over with 2 b's. So our answer is b squared. Again, bases are the same. We're dividing, so you subtract the exponents. 5 minus 3 gives us that exponent 2 that we found. Okay, looking at these examples, we have b to the exponent 8 divided by b to the exponent 3. The bases are the same, and we're dividing, so we're going to subtract the exponents. So that's b to the 8 minus 3. And our answer is b to the exponent 5. Our next one, we're dividing any like terms that we have. So first we can do 6 divided by 3. That gives us 2. Next we can do the a to the exponent 10 divided by a to the exponent negative 2. So we're same base, we can subtract the exponents. A to the 10 minus negative 2. And our b to the exponent 8 divided by b to the exponent 3. B to the exponent 8 minus 3. So simplifying that, we get 2a, and 10 minus negative 2 is really 10 plus 2, which is 12. And b to the 8 minus 3, which is 5. And our final one here, we have 10 to the exponent 5 divided by 10 to the exponent 3. Same base, we're dividing, so we subtract the exponents. 10 to the exponent 5 minus 3 is 10 squared. We can simplify this further. 10 squared gives us 100. Next, we have power of a power. So this is where we only have the one base showing, and we have two exponents that are side by side here. So that means we're going to multiply our exponents. So looking at the first one, we have 7 squared cubed. So that's 7 times 7 3 times. So the 7 times 7 3 times. We end up with 6 sevens. So we get 7 to the exponent 6. Since we have those exponents side by side, we would multiply those 2 times 3. Next one, we have 2 cubed, and that gets cubed. So that's 2 times 2 times 2, and that's going to happen 3 times. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 2s. 2 to the exponent 9. The other way we do this is multiplying the exponents 3 times 3, which still gives us 9. And the last one, we have c to the exponent 4, and that's squared. So that's c times c times c times c, and we're doing that twice. Okay. Counting up all the c's we have here, there are 8. So we have c to the exponent 8. The other way, we have the exponents side by side, multiply those. 4 times 2 is 8. Okay, looking at some examples. Our first one, we have x to the exponent 8, and that's squared. So we do have a power of power here, and we multiply the exponents. So x, and that's 8 times 2, so we get x to the exponent 16. The next one, we have 2x squared y cubed to the exponent 4. So this exponent 4 needs to go to every single piece that's here. So we're going to have 2 to the exponent 4 and x squared to the exponent 4, power of a power, we multiply those. So x 2 times 4 and y 3 times 4. So 2 to the exponent 4 is 16. And then we have x to the exponent 8, y to the exponent 12. The last example here. In the bracket, we have 4 squared divided by 4 to the exponent 5, and that's squared. So first we can solve what's in the bracket. We notice those have the same base, and there's division in between, which means we would subtract the exponents. So in the bracket, we'll have 4 to the exponent 2 minus 5, and then that will be squared. So we have 4 to the negative 3 squared. Now we have a power of a power, so we're going to multiply our exponents. 4 to the exponent negative 3 times 2, and that gives us 4 to the exponent negative 6. Okay, our last two laws we have our zero exponent law, and that's any exponent 0, your answer is always 1. So no matter what has the exponent 0, your answer will be 1. So looking at this one, we have b cubed divided by b cubed. They have the same base. We subtract the exponents, so that's b, 3 minus 3, which is b to the exponent 0. Again, anything to the exponent 0 is 1, so our answer is 1. And our negative exponent law, we have a to the negative n. So whenever we have a negative exponent, we can make it 1 over that positive exponent. We get rid of the negative because we made it over 1. So with the example 3 to the negative 2, we want to make that a positive. So we get rid of this by making it 1 over the positive power, 3 to the exponent 2. We could simplify this as 1 over, and 3 squared is 9, so we get 1 over 9 as our answer. A couple more examples here. We have our fraction 3 over 4 squared. Again, the squared needs to go to both pieces inside the bracket. So we'll have 3 squared over 4 squared. And that gives us 9 over 16. Our next one, we have 3 over 4 to the negative 2. So that's 3 to the exponent negative 2 over 4 to the exponent negative 2. In order to get rid of those negative exponents, we again make it over 1 to that power. So that's going to flip this fraction to become 4 squared over 3 squared, which will give us an answer of 16 over 9. And the last one, we have b over c to the negative 3. So that's b to the negative 3 over c to the negative 3. We want to make that positive. Both of those exponents are negative, so we need to make them over 1, which means we're going to flip the fraction and make it positive. So c to the exponent 3 over b to the exponent 3. So that is our note for today. You're going to be doing practice on your exponent laws using your textbook. Let me know if you have any questions.